Everyone. Today I'll be explaining two of the most important concepts in machine learning: supervised learning and unsupervised learning. I'll break them down in a very simple way so that you can clearly understand how they work and when we use each of them. Machine learning is a key part of modern artificial intelligence, but before we use any algorithm, we must know which type of learning our problem belongs to. In this presentation, I'll walk you through two main learning paradigms. First, supervised learning, when we learn using labeled examples. Unsupervised learning, when the system learns pattern on its own. By the end, you'll be able to choose the right method for any data science problem. Now, what is supervised learning? Supervised learning is like learning with a teacher. Here, we give the model labeled data. That means for every input, we already know the correct output. The model learns the relationship between inputs and outputs so it can make predictions later. For example, predicting house prices, classifying emails as spams or not spam. The goal is simple: use past labeled data to predict the new outcomes. Talking about the key algorithms here, some common algorithms used in supervised learning are linear regression for predicting continuous values, logistic regression for yes and no decisions, decision trees for simple rule based predictions, random forest to improve accuracy using multiple trees. These algorithms help us solve practical prediction and classification problems. Now, what is unsupervised learning? Unsupervised learning is the opposite. Here, the data has no labels, no right answers. Model tries to find hidden patterns on its own. We usually use this to group similar items together, explore how data is structured, and reduce data complexity. For example, clustering customers based on their shopping behavior. The key algorithms in unsupervised learning are some popular unsupervised algorithms: K-mean clustering, group data into K clusters; hierarchical clustering builds clusters step by step; PCA reduces data dimensions while keeping important information. This helps us understand data when we don't have any labels. Now let's understand the core differences here. Let's quickly compare the two. Supervised learning needs labeled data. Unsupervised learning works with unlabeled data. Supervised predicts specific values or categories. Unsupervised explore patterns and relationships. One focuses on accuracy, the other focuses on discovering structure. Choosing between the two depends on what data you have and what your goal is. Now, scenarios for supervised learning. We use supervised learning when we have labeled historical data, for example, past customer data with churn or not churn. Second, we want predictions, such as predicting future sales, detecting fraud, or forecasting demand. Now, scenarios for unsupervised learning. We use unsupervised learning when we want to find natural groups in data. We don't have labeled data. We need to reduce dimensionality for easier visualization. Examples include customer segmentation, anomaly detection, market basket analysis. Now, to make this more real, let's do a case study. For supervised learning example, we have healthcare. Training a model using labeled MRI scans marked as tumor or no tumor. And unsupervised learning as social media. Discovering trend topics or grouping users with similar interest without any predefined labels. This show how the learning type depends on the problem and data available. There are also hybrid approaches. In modern data science, we often combine these techniques. Semi-supervised learning uses a small amount of labeled data with large amount of unlabeled data. Then reinforcement learning in another approach where an agent learn by receiving rewards or penalties. The field is evolving rapidly, especially with self-supervised learning gaining popularity. Now, to summarize, supervised learning learn from labeled data to make predictions. Unsupervised learning find hidden patterns without the labels. Each has its own algorithm and best use cases. The right choice always depend on type of data and your goal. So yeah, that is for from my side. Thank you so much for listening. I hope the differences are very clear to you now and they are easy to understand. I hope you like my video. Thanks for watching.